Okay, now we're on our next unit, Unit 2. Our topic today is functions and relations. Okay, so relations, those are a set of ordered pairs, which may or may not be a function, okay? So for example, if I give you these ordered pairs in a set, that would be a relation, like 0, 2, 2, negative 3, 4, 4, 8, negative 6. Okay? So 4 sets of ordered pairs there. There are quite a few different ways to represent relations. The first one, and we're going to use the ordered pairs I gave you to represent all of these. The first one is a table, and we'll fill that out. The next thing is a mapping X to Y. Okay, then you obviously have a graph. Okay, and this one doesn't really have an equation, but I'll still give you an example anyway. Equation those are all different ways to represent a relation. Okay, so let's make these XY points I gave you into a table. So usually your X is in descending order or ascending order. Not descending, sorry. So low to high. So 0, 2, 4, and 8 are my X's from the lowest to the highest, because those are your first numbers of your coordinate pair. It goes X comma Y. So your X's always go first. Then the Y's I see with 0 is 2, with 2 is negative 3, with 4 is 4, and with 8 is negative 6. Okay, so those may go in order, they may not, doesn't matter. But your X's should go low to high. All right, so a mapping, you're going to map every X in the domain to its value in the range. Okay, so our domain is 0, 2, 4, 8. Okay, and now for this one, your range is also low to high. Okay, so they're both in order. So our lowest range here would be negative 6, because you're just saying a list of the Y values that were used. Then negative 3, then 2, then 4. Okay, so a mapping will map the domain to its value in the range. So 0 would go to 2, 2 would go to negative 3, 4 would go to 4, and 8 would go to negative 6. And that is a mapping. All right, so a graph of these points in this case is just going to be 4 ordered pair dots. Okay, so 0, 2 is what I see first. 0, 2. Then I have 2, negative 3. Ooh, this doesn't show the negatives. Okay, well, we're just doing examples, so we can just draw down here. So negative 3, 2, negative 3, here we go. 4, 4, 1, 2, 3, 4, 1, 2, 3, 4, and 8, negative 6. 1, 2, 3, 4, 5, 6, 7, 8, negative 1, 2, 3, 4, 5, 6. Sorry, I didn't realize that wasn't, these axes are making a L, not a T. So that was kind of a bad set of ordered pairs that I thought of. It's a graph with that graph, but that's okay. You get the point. So when you're given a list of points, you're not connecting them. Like this doesn't make a squiggly line. Okay, those are just a set of ordered pairs only, not necessarily a line. Okay, and then here's an example of an equation, not this equation, but y equals 3x squared plus 5. Okay, whatever. Any equation you could think of. Okay, so the domain and the range. Domain, to review, is the set of all x values. Okay, and then the range, the set of all y values. Okay? All right, so our next questions are given the domain and range of each function. So the first few are given points. So you're really just listing out the domain and the range. So number 1, domain would be your first values of every set of ordered pairs, because those are your x's. And we're gonna list them low to high. So the lowest I see is -5, then -1, then 3, then 7. That's the domain there. Okay, and then the range would be your second values. So, okay, and we're gonna list them low to high, and then we're also not going to repeat if they come up more than once. All right, so my range, the lowest value is -1. Okay, don't list it twice, just once, and then 0, then 4, because it's just a set of all the y's that are used. That doesn't mean you're gonna list them more than once. All right, number 2, you would want to find the xy coordinates of each of these points and then list out the domain and range. So I'm not gonna do that for all of them because I know you know how to do that. 1, 2, 3. So -3, -1, 2, 3, 4. You'd have to do that for every one of them. And then it would be just like number 1. You list the x's in order, you list the y's in order. So I think we got that one. All right, number 3 is a mapping. Okay, so our domain are all of your x values, -2, -1, 0, 1, 2, and it's a set. That's what these braces mean. It means it makes a set. Okay, and then range, set of all the y's, so 0, 1, 4. And mapping's nice because they're already in order from low to high. All right, now it gets a little trickier when you have a function, okay? So for domain, you're really thinking about, if you're thinking about the x-axis, which is left to right, and where your graph really starts and stops. Okay, clearly if it doesn't start or stop, you're gonna have some kind of infinity there or an inequality that just goes on from a value. And then your range, we care about up and down because that's your y-axis. Okay, and again, you're caring about where does the graph start and stop. Okay. All right, so let's do that for 4. So if I'm thinking of the domain, so where's my graph starting and stopping left to right? Okay, well, if I look at this graph, if you see the arrows at the bottom, it means that it's going to continue. It's going to keep continuing, and it's going to actually keep getting bigger as you go on, okay? There's nothing restricting it. So technically, if you think of this going on forever, it's going to get wider, wider, wider at the bottom, right? So it's going to be taking up all our domain, both directions, as it zooms out and gets bigger. Okay, that's called all real numbers because it's taking up all of the x's as the graph goes on and on. And I can tell it goes on because there's 2 little tiny arrows there, but that's why. Okay? So if you see arrows on both sides, most of the time the domain is all real. Not always, but most of the time. Okay, but y is a little different because there is a clear value which the graph is starting, and there's a clear direction in which it's going from there. So where's my y value starting on the graph? Like where's the highest point, in other words? That's at 6, right? 1, 2, 3, 4, 5, 6. And then the rest of the graph is really below this 6, okay? So when we're talking about the range, we're obviously talking about y. And it starts at 6, and then it goes below it, but it also hits 6. So that's your range. Y is less than or equal to 6. Okay, that's the highest point, and the rest of the graph lies below it. All right, number 5. So domain here has a clear, see we don't have arrows on both sides. There's a clear point in which your x's start, and then it goes off to the bigger x's, okay? For domain, we care about left to right. And so that's at -3. So we have x, we have -3, and it's going to the bigger, the graph will keep going to the greater than. And it's obviously included at -3, that's a closed circle. So that's the domain there. Okay, and in a very similar way, this will keep going up and up and up forever. So there is a bottom value for your y's, and it goes up from there. Okay, so the smallest y value is at 1, 2, 3, 4. That right here is -4. Okay, so we have y for range -4, and the function is going up or above that value there, so it's greater than or equal to. Okay, number 6. Domain and range here. So domain, you can see clearly there's what we call an asymptote right here. So it's not going to exist at that point, which is 3 on x, okay? However, think about it. Does the graph exist anywhere else, or where we're talking about left to right, right, for domain? So this is going all the way left forever and ever and ever, and all the way right forever and ever. So if there wasn't that asymptote there, then it would be all real numbers. But there's no value for x at 3. So it's just x does not equal 3. Okay, there's no value there. It will never touch 3. It approaches, but it will never get there. Okay? In a very similar fashion, where that yellow line is, that is your vertical asymptote, and that's at y equals 0. So these are approaching 0, but they're never crossing, okay? But for the y-axis, we care about up and down. So this line is going up forever, and down here is going down forever. So the only place we don't have a y value is at 0, because that's another asymptote. So when you have asymptotes like that, really, as long as the functions still have arrows on every side, you're going to include everything except where the asymptote is.